Okay, this is Isabella, and this is my oral presentation. So we have been asked to graph the following function. It's right here. It's a function of theta -3 cosecant 2 theta plus 1. So first, it's asking us to graph the function, right? Well, first we kind of need to know how to graph a function before we actually graph the function. So step 1 is to understand the parts of the trigonomic function. So this is just a basic example. And so right up here, you know, negative or plus in front of the entire function is a reflection over the x-axis. So a negative would mean instead of being up here above the x-axis, it would be down here below the x-axis. This a is in front of the trig function is the amplitude, which will be explained a little bit later. The number in front of the theta is the wavelength, or more commonly known as the period. The number added onto the theta is the horizontal shift, also known as the phase shift. And the number added onto the entire function is the vertical shift. Okay, so the amplitude is what stretches the function. It stretches the function up the y-axis. So for example, if you are multiplying the entire function by 3, so a equals 3, then it goes from a normal function to all the way up here. So how does that happen? So stick with our example, a equals 3. So 3 sine of theta is 3 times sine of theta. Same thing if a is 1 over 3. 1 over 3 sine of theta is 1 over 3 times the sine of theta. Or it can also be written as sine of theta divided by 3. Both of these are correct. They're just a different way to write the what it is. So the period is the wavelength. So for example, this is one wavelength. So the typical wavelength for sine and cosine is 2 pi. We're talking in radians. In degrees, that would be 360. So as you may also know, another sine and cosine directly correlate to cosecant and secant. And so we're looking at cosecant. So this is very important, and I'll come back to that later. So the formula is put our period above the b. Remember the b from up here? So the period above the b. In this case, the period is 2 pi. So 2 pi over b. And again, it stretches horizontally because the period is a set amount of how long the wavelength is. So if we're multiplying that wavelength, it will get longer, or it may get shorter. It just depends. So for example, if our b equals 3, that would be our period divided by 3. And if our b is 1/3, then it will be 2 pi over 1/3, which also translates to 6 pi. And so our phase shift is also known as our horizontal shift. So for example, if our c is +3, The plus meaning it is going to, the entire thing will move to the right 3 spaces. See, this would be our normal sine function. Then we have to move it 1, 2, 3 to the right because it is plus 3. So 1, 2, 3 units over to the right, and then starts our function. Now, if C was minus 1/3, now minus means you're going to move to the left this amount of units. So let's say this is our function. This is our original sine function. Now, if we're going to move it 1/3 units to the left, we're going to move it 1/3 units to the left. So it begins here. So now that we understand how to graph a trigonomic function and what makes up that trigonomic function in order that we may graph it, we need to understand the parent function of the cosecant function. So this is the parent function of this function. See, this is very complicated, but if you just break it down, it's just a cosecant function. Now that we know that it's a cosecant function, we need to kind of figure out and understand how to graph this parent function. So remember I mentioned earlier that sine directly correlates to cosecant. So it doesn't just directly correlate to cosecant. So sine of theta does not equal cosine of theta. Cosecant, my bad, cosecant of theta. Cosecant of theta actually equals 1/sine of theta. A little different. This is called a reciprocal. So how do we get from sine to cosecant? It's actually very, very simple. So let's say this is our original sine function. So to figure out where our cosecant function is, we draw these little arrows. It's like a parabola on top of our wave here. And then we take away the sine, the sine function, or my bad, the sine graph. And we're just left with the cosecant function. So now that we understand a little bit more about this cosecant function business, we need to figure out how the parent function changed so that we can get our current function. So we're starting from here and we're trying to get back to here to understand how we're supposed to graph this one, since we already understand how to graph this one from right here. Okay, so now we just break it down. Very easy, very simple. So this negative here means a reflection over the x-axis. Now this 3 in front of the function is our amplitude. So that means that our function is going to be stretched horizontally. It's going to be stretched horizontally. And our 2 in front of the theta is how our period is changed. So remember our period was 2 pi. So now and our 2 beside our theta is what is going to change our period. Remember our period was 2 pi over b. That was our formula. So we take our 2, we plug it in for b, then we cross these out and we just get pi. So pi is our period. And our +1 at the end of our big function is our phase shift. And because it's plus, we are going to shift a certain number of units to the right. and plus 1 means we are going to move 1 unit to the right. Step 4, we finally get to graph it. That's what y'all are here for. Yay! Okay. And so, quick reminder, we graph it like a sine function, then we add the cosecant function, and then erase the sine function. So 3 steps in the graphing process. So first, we graph our sine function. Then we add the cosecant function, our little happy faces and sad faces. Then we get rid of the sine function, so we are just left with the cosecant function. So this is what our finished cosecant function will look like. Ta-da! And finally, that is the end. That is how you graph our beautiful little cosecant function that we started out with. Okay, I hope you guys enjoyed, and yeah, I hope I explained it well enough.